Okay, in this video we're going to take a look at what light waves are and what the electromagnetic spectrum is. So to begin with, let's think of an electron. It could be any charged particle, but let's think of an electron. And we get this electron oscillating back and forth. Think about oscillations in our waves and sound unit. Imagine you have the end of a slinky oscillating. It might make waves form on the rest of the slinky. And in the same way, this oscillating electron would create waves moving up and down. These waves would be electric fields. We have an electric charge, so this would make an electric field oscillating up and down. Well, one of the interesting things that James Maxwell came up with and is famously published as Maxwell's equations is that there is a relationship between electricity and magnetism. This is one of the ways that we can show Maxwell's fourth equation actually in vector notation, where the B represents a magnetic field and the E an electric field. Anytime you have a changing electric field, we get a magnetic field. But as well, anytime we have a changing magnetic field, we get a changing or a curling electric field. So electric fields make curling magnetic fields make curling electric fields. So as a consequence, we will have a magnetic field produced in tandem with this electric field. And I'm going to attempt to show this moving perpendicular to the electric field. So this is the magnetic field. I'll call it M even though they have B here. So light, we can think of light as a wave of electric fields moving in tandem with a wave of magnetic fields, hence electromagnetic waves. Well, it's common to think of electromagnetic waves forming with a variety of different wavelengths and frequencies. And this is where we get the spectrum. The spectrum would be any array of something that can be quantified from one extreme to another. So from the longest waves to the shortest waves, or from the lowest frequency to the highest frequency. So just to get a basic understanding of this, humans are able to see a very narrow region within this electromagnetic spectrum. The longest waves we can see are red. The shortest waves we can see are violet or purple. And red, orange, yellow, green, blue, and indigo are in between. So these are the light waves that we can see. They're electromagnetic waves that the human photoreceptors are sensitive to. However, there are electromagnetic waves that are longer, do not resonate with our eyes, and as such we can't see them. And there are electromagnetic waves that are shorter, and we can't see those as well. So just to mention a few things about these, the longest waves we have are radio waves. Longest electromagnetic waves, they could be AM radio waves in the gigahertz or in the kilohertz range. You can have FM radio waves, and these have been used for telecommunications for a long time. Microwaves are a little bit higher frequency than radio waves. Our cell phones communicate in the microwave region of the spectrum, and of course our microwave ovens also cook food by sending light waves within this region into food. It actually causes water molecules to start wiggling, and that's why the food heats up. As we move up, infrared. Infrared are waves that are longer than red waves but shorter than microwaves, and they are invisible to us, but we can sense them because infrared is how we sense heat. So hot things radiate out infrared radiation, and if you were to hold your hand in front of an infrared source, you would feel the heat. It would cause your molecules to start vibrating faster, and you would sense that as heat. These, of course, are the ones we can see, but beyond the violet, other invisible light rays UV or ultraviolet, just a little bit higher frequency than violet. Now these are responsible for suntans and sunburns, but the same ultraviolet light is also what allows our skin to make vitamin D, a necessary nutrient in our bodies. X-rays are just beyond the ultraviolet. X-rays are much higher energy, shorter waves, higher frequency. X-rays mostly go right through us. However, they're blocked by bones and other structures. So X-rays are a useful way to see a shadow of the bones in our bodies. And finally, gamma rays. Gamma rays are high energy, high frequency electromagnetic waves that are produced in the nucleus of an unstable atom. They are produced when atoms undergo nuclear radioactivity or radioactive decay, and they generally go right through us, although they can be a dangerous cancer-causing wave. So from the benign radio waves that go right through us and allow us to listen to B96 and US 99, to the visible light waves that allow us to see and allow plants to undergo photosynthesis, to X-rays, which show us whether we have broken bones and cavities, to gamma rays, which generally go right through us. We have the full spectrum here. The only difference between gamma rays and radio waves is the frequency at which these electric and magnetic fields oscillate. So that's the basics of light as an electromagnetic wave.